What else is that common difference? Let's see. We're given a fourth term, which is this guy right here. And we're given a 13th term, which is this guy right here. And then it says, write the first several terms of the sequence. Okay, in order to write the first several terms of the sequence, one way we could do it is finding the nth term. If we find the nth term like we do on a lot of these problems, it makes our job really simple. So I'm going to write this two different ways. I'm going to write extra stuff. I'm going to write the extra stuff in black, but then the stuff I write in blue is the stuff that you would actually have to do in order to find this. Let's see, they have our right. They've given us the fourth term, which is 20. They've given us what was the other one? The 13th term, which is 65. Okay, so if I write this out, I'm going to call this one my first term. And then we have 2, 3, 4, so the fourth term, which we're given to be 20. And then we have 5, 6, 7, 8, 9, 10, 11, 12, 13. 13th term they've given us, which is 65. And so the big question that you should be thinking of right now is how many times do we add the common difference to get to that term? Okay? How many times do we have to add the common difference to get to 65 from 20? That'll really help. You guys got 9? Yes, and the way you would find that is by just going 13 minus 4 or writing it out like I did it and counting it. So there's 9 times. We have to add the common difference. 1, 2, 3, 4, 5, 6, 7, 8, 9 times to get to 65, which is an important number. And then the other thing we have to know is what is the difference between 20 and 65? So we would go 65, we subtract the 20, we get 45. So this is the difference, and this is how many times we have to add the common difference to get there. And so if you guys wanted to find the common difference, you would take the difference, divide it by 9, the number of times you have to add it, and you get 5. So this is your common difference. Now, if I was trying to write the nth term, the formula for the nth term, it would be a sub n equals a sub 1 plus n minus 1. Remember, we went over this yesterday. D times d. And so we got to plug in right there the first term. We got to plug in right there the common difference, which we know to be 5. What is the first term? Ooh, and this is one way you guys can do it. You guys can go up here, and you could just count back 5 every time. So what would this number be? And what would this number be? 10, right? And what would this number be? 5. So we can find it that way. But let's pretend that was too much for you guys. You didn't want to count back because it's just too much. So what you could do to find a sub 1 is you could use one of the terms that you're given. Like we can use this one. You can use the other one too. But I'm going to use this one to find my a sub 1. So I'm going to plug in 20 to the a sub n part because that's the term. And then I'm not going to know a sub 1. And then I don't know. Oh, I do know the n. What's the n for this one? What number term is this?
4.
So I have 4 minus 1, and I know the common difference to be 5. So see, I only have one variable. I can solve for that, and we can find it. Now we know it should be 5, but let's pretend that was too much for us. We didn't want to count that much. So we set up this equation really fast to see if we can find it another way. What is 3 times 5?
15.
So you have 15 plus a sub 1 equals 20. And so you subtract 15 from both sides, and you get 5 equals a sub 1. Now this is extra right here, because especially for this one, we could have just counted to find that number, a sub 1 equals 5. So over here I'm going to put 5, and then I'm going to simplify this dude. So a sub n equals 5 plus, now I'm going to distribute this 5, okay, to both of those. So we get 5n minus 5, and when I simplify this, I just get 5n. So this is my a sub n. If I want to find other terms, I can just plug the number into this to find the other terms. So you see, all the stuff in blue is the stuff that is crucial that you would have to write to solve a problem like this. I mean, it's not crucial. I mean, this is a pretty low-level problem. You probably could have just counted it out yourself. But let's go ahead and write out some of the terms. We got 5, 10, 15, 20. We're just counting by 5s, huh? 30. How many do we write? Well, it doesn't really say. It just says first several terms, which is an annoying, ambiguous type of a problem. I like the problem that just says find the nth term, because once you have the nth term, you can find any term. All right, that one's done.